Great to be with you again.
So I'll just start. I mean, we already have questions in here, so just raise your hand if you'd like to ask a question or type questions into chat. You know the deal by now. This is the last mentoring session, so we're just so grateful for you to be here and for to complete this journey together. We've watched all the modules together, and here's our grand finale here. So just for the sake of time, for everyone's time, to honor everyone's time, Nassim, I'd like to just get right into it. Would you mind if I pose a question to you here from our
Oh,
audience?
go ahead. Yeah, sure.
Okay, so we actually have a few people writing in about this relationship between stillness and spin, and particularly, I think Janine puts it in a nice way. She says that she quotes you as saying, "Stillness is the accumulation of all spin." And she says, "I understand spin. I would love to have Nassim explain how stillness is the accumulation of all spin. How do we reconcile these two concepts?"
Yeah, it's a hard thing to explain because it's a nonlinear concept, and you would think it would be simple. Spin seems obvious and simple, and actually spin, gyroscopic effects, and angular momentum and all these things are actually not that well defined by our physics today. For instance, there's a problem with the observer, right? So if I put a wheel between you and I, do you bring those people on when I answer or no?
We can. Well, Janine, if you don't mind raising your hand, if you're with us, Janine, I can pull you right on here.
Oh yeah, it's hard to find them. So basically, think of it, if I had a wheel between you and I, and let's say a bicycle wheel, and it's spinning clockwise for me, it's spinning counterclockwise for you. And so, hi, Janine. Nice to see you.
Do you have any clarifying points for this, Janine?
The only thing I could come up with is the eye of a hurricane, but I don't understand that either. So I really want to hear what you have to say, Nassim. This is awesome. Thank you.
That's good. An eye of a hurricane is a good example. Where are you at, Janine?
I'm near Portland, Oregon.
Oh, right on.
Yeah.
So if I have a wheel between you and I, and I'm on one side, you're on the other, I'm gonna swear to you that the wheel is going clockwise, and you're gonna disagree with me 180-degree phase from me. You're gonna say it's going counterclockwise. I swear to you, it's going. And we would both be right? We would both have an actual measurements that we can, provide. That, like, if we take like a knob on the bicycle wheel and we trace it over time, that it's going in clockwise direction for you, for me, and counterclockwise for you. And we could argue significantly about the direction of movement of that wheel. But
is that why you say there's only two directions, in and out?
Correct.
Okay.
Right. The only thing we would agree on is that the hub of the wheel is not spinning.
But I don't get that. I can't picture that. Like, if I think of spinning myself, I can't picture that any part of me is not spinning. So that's the part I need help with.
Yeah, well, the central axis of what you're spinning on, if it was very precise, right, would not be spinning, right? Like, so think of it this way. So the universe is a little more complex. But the universe has all of the frames of reference looking at the wheel, right? The universe is looking at the wheel from all sides, right? It's looking at all the galaxy from all sides. So how does it, so let me put it in a bigger context. If I have a planet that's spinning, right? Mm-hmm. And I'm being honest about the dynamic of that spin. If I isolate it, okay, I can, say it's going at this speed and it's spinning, and as it's going into the orbit, there's this speed. So I would have to account for that because it's spinning around the sun, right? Mm-hmm. And then the sun is spinning inside the galaxy, mm-hmm. right? And then the galaxy is spinning inside the cluster, and the cluster inside the supercluster. And that's, I'm going to assume, a universe that's spinning, and it's in a larger universe that's spinning, and so on. So, the movement of angular momentum in any given place, is in relationship to all the scales. If I went down, it's the same thing. It's made out of atoms that are spinning, that is made out of, subatomic particles that are spinning, and so on. And so then, so stillness is like if I took all of those spins to infinity and summed them all, they would cancel all out to not.
Because some are going one way and some are going another way.
That's like, right. Yeah, and so the hub is a singularity, is a black hole, because it incorporates all the information of all spins in the universe.
So I was just thinking about, the double torus and thinking, well, if somehow that central aspect of the double horse is creating the spin.
So yes, so more stable is the stillness in the middle, stronger is the hurricane, right? Mm-hmm. So more if the center is wobbling a little bit and all this, it takes away energy from the system. But if it's really strongly still, then the system spins at very high velocity. Faster it spins, stiller the center is, right? The eye of the hurricane. Like you can literally be in 300 kilometers an hour winds on the edge of the eye of a hurricane and almost instantaneously be in, perfect stillness.
So is it somehow pushing out a center right. Of stillness?
Correct. It's the angular forces like centrifugal forces, gravitational forces, and so on, electromagnetic forces as well, produce a balanced situation so that the center is stillness. And that's what allows the spin to occur, right? Without that, the system wouldn't form. It needs that stillness in the middle. It needs that singularity in the middle. And it's not well understood. That's the thing. It's that people don't realize that a lot of physics that we think of every day and that we use every day is actually fundamentally not well understood. For instance, if you look at trying to find equations that describes the fluid dynamics of a hurricane or a tornado and so on, it's actually very loose. There's a lot of talking with the hands. There's not so much, formal equations, analytical solutions to fluid dynamics and so on. So those things are hard to resolve. We are resolving them in space-time in the paper that I'm writing right now. So from space-time interaction, from Planck vacuum interaction, we actually, as we write the equation, the Navier-Stokes equations come out, which is fluid dynamic equations naturally. There's $1 million prize for that, by the way. Hopefully we'll get it. But you know, this is it's people think physicists have, even physicists think that we have these things resolved, but we don't, right? Because the physics we have today are not this correct. And sadly, when physicists get trained, when scientists get trained, they don't get point out those points because the teachers don't even know, right? For instance, you get taught Maxwell's equations, right? And you get taught that the energy and the power of an electric field goes through a wire. It's absolutely completely wrong. Like Maxwell's equation don't say that at all. It says that the energy is actually going from the source, which would be a battery or, you know, a source of energy, to the load, you know, outside the wire, right? It's not, it's in the field, right? It's not in the wire at all. And actually, Feynman made lectures about this that created all kinds of issues. Veritasium just made a video on it. If Veritasium is
I saw that. Nassim, that was awesome. Thank you so much. I see that a couple of our friends here are probably ready for their next question.
Yes. I hope it answered your questions a little bit.
It did. It made me feel like I want to be that eye of the hurricane.
Exactly. I was going to say philosophically, it's really important because that's what meditation is. It's going to the center, to the stillness, so that you can be more still. And when you're more still, then your hurricane, your energy goes up, right? And your power of influence goes up.
Thank you so much.
My pleasure.
To hear from Dave and Carla.
Great question.
Okay, thank you.
Thank you. Hi.
Oh, wait. Hey there, David. How are you today?
Carla?
Yes, hi.
Hi. Nice
hey there.
to meet you guys.
Yeah, we had a chance to speak a few years ago. Marshall Lefferts hosted the Universe, the Connected Universe film, and you and I got a chance to speak about a Council Rocks archaeology site I'm working on.
Yeah, I remember.
Well. Yeah,
how's that going?
Very well. Actually, just recently found out in the last few months through LiDAR studies that the 4 main boulders aligned with the solstice equinox are they're like Orion's belt. There are actually 4 large boulders out that are like Betelgeuse, Bellatrix, Sirius, and Rigel, or Saiph and Rigel. The site is way more amazing than I thought. Basically.
Which site is that?
It's called Council Rocks in Pennsylvania.
Oh, wow.
Yeah.
And they did LiDAR studies on it?
Yeah, I actually hired a guy to come in and do LiDAR studies. And when he did, I noticed that the 4 main stones looked like the belt of Orion because there were awesome. 2 outlying boulders. And I thought, wow. So I had him do more LiDAR scans and he uncovered other boulders and then I had a physicist, a NASA researcher, actually do an analysis on it. Came up to it, did only a 4.5% error numerically from the boulders to the Orion constellation.
Wow, that's remarkable. Are you going to publish with him?
I hope so. I've never written a paper myself. I'm asking for his help. His name's Mark Carlotto. Hopefully he'll help me.
Great job.
Yeah,
and
thank you
to him for helping. Yeah, please publish. That's really important.
Well, you told me years ago, you said, just keep going and going. And I keep going and going, no matter the resistance.
Good job. Good job.
Thank you. Thank you. Yeah. So related to Janine's question, because this stuff all ties together. You know it. I know it. We feel it. That stillness is what brings it about. So similar to the eye of a hurricane and the stillness, my question is on a black hole, whether it's especially a galactic type black hole, is your description of the toroidal and poloidal effects, how it's always moving. would the center of that black hole be a geometric crystalline structure of infinite mass, or is it actually a perfect vacuum energy?
Well, yeah, okay, so going along with what I was saying earlier, that's another thing that physicists think we have figured, and we absolutely don't. We actually don't know how a Faraday motor works. Right? Like the first electrical motor, right? We actually don't know how it works. We have some theories. They don't add up because there's a problem with the frame of reference, meaning you can have, just a magnet spinning with nothing around it that produce power, right? So what's the frame of reference? Where is the stator, right? Everything's spinning, right? And there's the Einstein-Haas effect. And anyway, there's many things that we think we have figured, and we absolutely don't. And one of those is singularity at the center of a black hole. So you're asking a question about singularity,
exactly,
which is complex. My theory, starts to give a sense of what that is, and again, the frame of reference issue shows up in black holes because depending on which frame of reference you take, you get singularities or not at the event horizons. So typically, the frame of reference that's taken is of a stationary observer outside the black hole.
Right.
If you take that coordinate as the frame of reference, then you have a problem because whatever is falling in the black hole, from your perspective, is slowing down to infinity because it's approaching the speed of light, and it ends up being frozen in time on this. And so you have a mathematical singularity that shows up in your equations. But that's an illusion. That's an illusion. It's a mathematical illusion. That's from not taking the proper frame. The proper frame in physics is the frame of reference, or the coordinates of the particle that's falling into the black hole. From its perspective, it's not seeing any event horizon. It doesn't give a shit. It's just going, and it just keeps accelerating past the speed of light. Right? Now they might be the equivalent of a sonic boom, which would be a light boom, which would be like an hydraulic jump at the event horizon that it might experience, but that's another thing. But you can imagine that particle is going towards singularity, right? Now that singularity in the middle is not a mathematical illusion. That one is real because gravity there goes to infinity, right? Energy goes to infinity in the middle.
Yeah.
Okay, so your question is what does it look like in there? Right?
More or less, yeah. Is it a vacuum of infinite energy, or is it a particle, substance of infinite mass? And yet, I get what you're saying. It depends. Yeah, it's both. And it's not. It's in effect, it's not a singularity at all.
Mass and energy are equivalent. Yeah. So you have infinite energy, but you have. Okay, so I want to moderate that. Standard model has no clue what's happening in there, okay? From holographic fractal physics, what's going on in there is that it's the center of the vortex. It's the stillness at the center of the vortex. And it has generated, tunnels in space.
Right.
The singularity is connected to vortices, right? Tunnels in space that are very large. For quasars, it's like million light years long, or for galaxies, it can be even bigger. And it's spinning at near the speed of light. Okay, so this is the wormhole. This is the wormhole. It's the entrance of the wormhole that connects everything. So when I'm saying it has infinite energy, infinite mass, in the standard model, it's like a very esoteric thing that you just say that, and it's like, you know, nobody knows what that means. In this context, I'm saying it has that because it's connected to all the other things in the universe and the multiverse, to infinity. Yes. That's why it's infinity in there. And so
in essence, yes, it's not even a singularity because it's connected to everything.
That's right. Yep. Exactly. And so this is why if you're going to travel through the universe, you're not going to do it at the speed of light because it's going to be way too slow, right? It's way too slow. And you're going to need to jump wormholes somehow, right? Because like at the speed of light, take you millions of years to go across the galaxy. Like it's just not feasible, right? Even just going at the speed of light to Neptune, right, would take you 13 hours, 14 hours or something.
Right.
So, you know, we want to go faster, right? So you would then, you can imagine then that like you could accelerate into a singularity, enter the wormhole network, and, you know, transfer your information anywhere in the universe you want to, or the multiverse, or any other. So then they would be very specific paths. You would be jumping from one hub to the other, right? Like from our sun, for instance, into the galactic center, and from the galactic center out of another star. And then, you know, now this is much more advanced technology than we have today. However, you'd be surprised. We might get there pretty quick. You might be able to do that without having to jump in the sun. You might be able to accelerate yourself. If you have a gravitational drive that warps space-time, you might be able to accelerate yourself. So you make a singularity in front of the ship. This is how you're moving through space. If you cohere that singularity, if you create that vortex strong enough, you might be able to get to an energy level in which the ship goes through, you know, you've made your own little black hole, if you
constructed it.
Yeah. And then now you can transfer the information anywhere you want in the universe.
Yeah, I just read an article on that today. Nanoscale wormhole created NASA. You know, some laboratory did that, and I thought of your work because again, it's the infinite vacuum.
Well, yeah, very good, Dave. You know, like when I talk like that, people think, "Oh, this is so far in the future." You know, it's so out there, but it's actually right at our doorsteps right now.
Yeah.
Yeah.
And if you do go within, I'm a firm believer. I've had one experience of that about 20 years ago, of being able to be anywhere, anytime, just by thought.
Yeah.
I don't know how that happened, but I felt it. So I believe it's real.
Well, you know, your atoms are made out of singularities.
Correct.
Of black holes. This is what my theory proves. And the paper I'm about to publish is going to prove it, you know, without doubt. And so I see no reason why you couldn't transfer your consciousness to anywhere you want at any time you want. Yeah. And I think that's why things like remote viewing have been confirmed. Those were remote viewing tests were published in some of the largest physics journals in the 70s by the CIA and so on. And so, you know, the fact they were pulling students off the campus in Stanford that had no psychic special ability or, you know, anything like that, and just sticking them in the room and getting them to remote view a target, you know, in Russia or another, you know, whatever. And the people were like 80% accurate, you know. So it's not anything that you have to be like in a cave, you know, being a guru for like, 5,000 years, although some of those students might have had lives like that. But, what I mean is it's accessible because you're made out of that stuff. And that's,
we all have it.
We all have it. That's right. Carla, did you have a question yourself?
I don't. No, I really enjoyed listening, and I'm totally learning a lot. And I've had similar experiences. Maybe if I can make one quick comment. I study dreams. So even in the dreaming world, you know, the subconscious, you know, obviously that's connecting to the field. And that's been my experience. Just learning my own, working with others, having dreams with people in his life from the past that I've never met because I don't think I was alive. And like telling him, and he's like, oh yeah, that's so-and-so. I'm like, why would I have a dream about that? And yeah, all kind of really cool experiences in that realm. So
very good. The assumption that dreams are not real is a very tentative assumption, right? Mm-hmm. Meaning from the dream world looking at us, they could say the same thing. Right? So you see, I many gurus throughout history have talked about how it's all an illusion. I like to think of it as it's all real, the whole thing. And I think when they were talking about how it's all an illusion, what they really meant is that thinking that reality is not real is an illusion, right? Meaning that reality has a reality behind it that if you only look at the atoms, you're gonna miss. Yeah. Right. And so in what they meant is that thing you're seeing is making you miss the reality below it. But not that it's an illusion that it's not part of the universe. It totally is. The whole thing is real. Right. What you call your imagination, what you call your dreams, the whole thing is real. What we call spirituality, all this, it's all real, right? Including the matter, because the matter is made out of all the same thing. It's all one thing, right?
Cool. Well, thank you. Thank you so much. We should move on.
Thank you.
Thank you very much.
I appreciate it.
Oh, yeah, you too.
And Nassim, we have another caller in, Linda, with a question.
Linda, hi.
Hi, Nassim. I'm so happy to be here with you today.
Thank you, Linda. Where are you from?
I'm from Worthington, Ontario, Canada.
Oh, wow.
Yeah.
Go Canada.
It's winter here, so it's cold.
Yeah.
Nassim, I'm very passionate about protecting our rivers. And right now in Ontario, there's a whole new push for hydroelectric power generation, building new dams. So I'm very interested to know more about what you said in your last session, being able to pull energy out of the field. I'm wondering, if you're working on that, when we might expect that to happen, how it would happen. I'm very interested in that.
Gonna have to plead the fifth on that one. Well, first of all, the ecological disaster that hydroelectric dams, nuclear power, coal power production, even solar panel and eolians is just remarkable. We've had to do it to get to this point, but now it's time to switch to a new source of energy. That source of energy is in the structure of space-time, is a source of energy that produce all of the atoms, all of reality. It's very much available. It's very much there. It's not, you know, people think of it as subtle energy. It always makes me laugh. It is nothing, absolutely nothing subtle about it, right? Like zero. It's like 10 to the 93 grams per centimeter cube, which is more than all the energy in the universe in a centimeter cube of space. It's not subtle. It's more like, you know, a raging river. And, you know, that raging river makes atoms and galaxies and stars and quasars and pulsars and universes, and you know, it's not subtle. And all that stuff is serious amount of energy. I mean, look at our local star. It's serious amount of energy, right? Now, using a crystal to like bounce off some of the photons from the heliosphere of our star to get a little power generation in the solar panel is, it's okay. The efficiency is like 13%. It's horrifying. But there is a much better way to extract that energy. We have to put the hydroelectric power, you know, turbines in the flow of that raging river. And am I working on this? Well. I have been for the last 30 years. I've had multiple laboratories. I've had financial issues financing these laboratories. You know, I've probably raised over 25 million over the years, 30 million. But in physics, 30 million gets you a few instruments on the table, right? It's, you know, this is why experiments in physics, like fusion experiments, cost billions of dollars, you know, accelerators cost billions of dollars. So the problem is that there has to be, first of all, an understanding, a comprehension that this is a possibility, which is really hard to convey to a bunch of, you know, financing people or, you know, or governments and so on, because they don't understand physics, they don't understand, and then they turn to the mainstream and ask, is this possible? And of course, the mainstream goes, no way, you know, not possible. You know, because they don't understand physics, because they don't understand the universe. But they think they do because they've been taught Maxwell's equations and ignored the part that they didn't understand. And so they think they actually understand Maxwell's equations. You know, they actually, which Maxwell's equations were written with an ether, with the vacuum fluctuations, you know. Anyway, don't get me going. So, Linda, it's gonna happen. I swear to you.
In my lifetime?
No. I swear to you, it's gonna happen. I was gonna say something that I don't want to say, but so I'm just gonna say it's gonna happen in the next 2 years.
Oh, that's wonderful news.
Yeah. And it's gonna revolutionize everything we do and change everything we do. And yes, those devices exist and they function and they have no input power and they produce power directly out of the structure of the vacuum and so on. They exist. It's just they've been in garages of, you know, garage inventors all around the world because they are really difficult to finance and to do research on. And it should be the first thing on the agenda of governments to do research in this field. It should be millions, if not billions of dollars should be invested immediately in extraction of energy from vacuum fluctuation, which is totally feasible, is totally possible. And this paper I'm going to publish is really going to make that clear.
That's wonderful news. Right now, they're putting new transmission lines all over the place. They're pushing for all new hydroelectric dams. And they proposed 87 projects on rivers in Ontario. And yeah, it's just archaic. It is archaic. And so that's good news. And will we be able to hook up to this from our homes, or will it be?
So initially it might be that the current grid may be used, but that's gonna go really fast because these devices are fairly small and efficient. You know, you will be able to have one running your house, one running your car, one running your laptop, run, you know, so power will be completely decentralized. You'll have a way to access power anywhere you are in the universe at any time, you know, because it's in the structure of the vacuum. So
can you tell us how we can support that work?
Become a member of the Resident Science Foundation, send us donations, do everything you can to support us financially. If you know people with good resources that can finance, you know, $200 million labs and so on, that's what we need. Like, and it's not out of reason. It's absolutely reasonable. That's what we need. And that's and it will save humanity, and we will. It's on its way. It's on its way. There is no, like, I'm just gonna say, you know, I'm talking from direct, you know, it's on its way.
Thank you.
But really, supporting us financially makes a big difference. Even just $5 a month, being a member of the foundation makes a huge difference. Like, I can't explain how, like, that, you know, goes to us being able to hire physicists, to hire engineers, to, you know, to like get the job done, have the power to function independently, you know, and not be tied into systems that are counterproductive. So, you know, this is where it's at. It's by the people, for the people.
Wonderful. Thank you, Nassim, and thank you, Linda, for the wonderful question. Boy, that's a powerful piece to bring in, I'd say. Yes. And without further ado, Lloyd is on here with the question. Hey, Lloyd.
Hi, Lloyd.
Hello. Can you hear me?
Where are you at?
I'm in California.
You're in a beautiful black triangle.
Yes, I call this my regeneration station. It's actually a pyramid that I built. And
oh, nice.
So yeah, I can sleep here and meditate here, and it regenerates me.
Nice.
So my question is, if I were these extraterrestrial beings that modified humans 200,000 years ago, I would stick around, and like any parent, I would make sure my kids are okay. And there's evidence that they've done that, and they're still present around here. But my main interest is, how can I connect with my celestial brothers and sisters, like in a real tangible way? You know, I've attempted this through Stephen Greer's work a little bit with his CE5 meditations. But yeah, I'm interested in more guidance about how can I connect with our ancestors.
Did you see some interesting things during your experiences with my brother?
I have a little bit. I feel like I'm just kind of scratching the surface.
Right.
I have another pyramid outdoors in my backyard, and that's where I do the CE5 meditations. And,
I see.
And I'm actually considering building a cube octahedron in my backyard as well.
That's good. That's good. Well, yeah.
And I figured he would attract these guys, you know, they got the pyramid sitting right there in the backyard. It's like, where are you guys? Come on down.
You got to realize, first of all, that like, imagine you were them, okay? And you were, you know, looking at the earth from space, like far, you know, like you're beside the sun, kind of looking at the earth from space, you know, and you're thinking, wow, you know.
Oh my God, what are they doing down there?
And you tap into the local like CNN satellites and you get the feed from the 5 o'clock news, right?
Yeah, so why aren't they helping us more?
Yeah. And then you know that if you enter the airspace of that planet, it's gonna be, you know, you're not gonna be kind of like greeted with like the red carpet and like, you know, oh, it's so great to see you guys. You know, it's more gonna be like shoot first, ask questions later.
It's a hostile environment. But what about this one guy in California with the pyramid in his backyard? You know, can't they come visit me?
Right. So yeah, but you got to remember the airspace in Canada and most Western countries and others is not free of radar, right? So it's not easy necessarily for them to just show up, right?
Agreed.
So yeah, so you're beside the sun looking at all this data from where Earth's at, or maybe you're in the backside of the moon, right? Where you have that nice little base, you know, that you can observe humans from. And you turn to your crew and you say, okay, right, now that we've studied what they're doing down there, who volunteers to go? And right? And you know, most of the crew is like, oh, I've got an appointment at the dentist on the other side of the galaxy, right? So basically, it's quite dangerous for the galactic community to come down here. And so, you know, you might consider that there's ways of contacts that are not necessarily direct, but that are available to you through your consciousness as well, you know? And
yeah, I've already been exploring that and I've had some success, but I'm more interested in, like, you know, going for a ride in the ship for a while.
Yes, that is fun. I had some of those experiences as a child.
Great.
But you have to consider that many people would love that. And it's not necessarily easy for them to be able to do that. And, but it's not impossible. That is, continue your exploration, continue to connect with them, continue to put your intent out, maybe go on journeys, you know, in regions of the world where it's easier for them, you know, and so on. You know, might think of South America or, you know, Africa, I don't know, you know, places. And that might become a possibility for you to go on a ride. But I'm going to suggest to you as well that you're patient, and that it might not be that far in the future where we're going to have direct connections, direct interactions with them publicly, globally. I don't think we're actually that far from that moment. And that's why the Vatican and the governments are releasing more and more information, is because they know that's on the way. So, you know, It's a long journey. I know the feeling. I've been there, you know. I know the feeling, you know, and Stephen is doing really great work. So I encourage you to continue, and we'll get there. And hopefully, you know, when they pick you up, you know, stop by my house, pick me up on the way there as well.
The next CE5 is this Saturday.
Wonderful. Yeah. So where are you at?
In California, Northern California.
Northern California. Okay. Yeah. So, yeah, I mean, there's a lot of activity in California. A lot of the video footage, for instance, that was released by the military industrial complex in the last few years comes right here from beside me in San Diego. So, you know, there's quite a bit of activity in California. Let me get in trouble some more with this session. When I was in Northern California a few months ago, I saw a whole fleet, low altitude, right beside me, fly a very beautiful flyby of 10 ships, glistening in the light of day. You know, clearly you could see the fuselage too. It was beautiful. It was completely silent. So they're around, you know. So
one time I saw 9 lights in a perfect square shape, you know, three lights, and they just kind of appeared and then disappeared. And I was wondering if those were extraterrestrials or maybe some new kind of satellite system they're putting in or something.
I wouldn't be able to tell you, but yeah, they're around and they're listening, you know. Don't give up.
Okay, you guys, let's connect. I'll let somebody else go. Thank you so much. That was awesome.
Thank you.
Thank you for the question. We have Rosemary on here. Rosemary, let's see if we can unmute you here.
Hi, Rosemary.
You have your quick question for Nassim? We're on low time. You have to mute.
Oh, you're muted. You're muted.
Hi.
There you go.
Okay. Yes, one of these senators from my state was an engineer and a scientist, and he appears to be interested in alternative energy. He's also, you know, he's kind of he kind of goes back and forth a little bit, but he has written in his letters to his people that he was a scientist before he was a senator, and now he's very interested in alternative energy.
Which state are you in?
Sorry?
Which state are you in?
New Mexico. He's Senator Heinrich.
Oh,
so
okay.
do you want me to refer him to you?
Yeah.
Residence?
Yes, please.
Okay.
Yeah.
And the other thing I want to say is I'm an astrologer. And in a couple of years from now, the planet Pluto is going to be trining the planet Uranus. And for an astrologer, that is absolutely phenomenal, huge energy. Pluto in Aquarius, Uranus will be in Gemini, which are good places. Uranus and Gemini is just brilliant. And they're going to be trining each other. And I've been kind of looking at this, and for me, that can either mean that can either Sorry?
2024, 2025?
I don't know. It's around that time. I'm going to have to look it up exactly, but it's coming soon within the next couple of years. These kinds of energy could mean a world war, or it could mean absolutely phenomenal breakthroughs in technology, because Uranus is very much a technological planet. I think it's going to be a revolution in technology. And when you're saying in a couple of years this is coming, it's like, oh, that makes sense. I've been thinking about you ever since I realized that this trine was coming up. And I was like, it's Nassim. It's about Nassim. And I just wanted
I'm going as hard as I can to get it out there.
Yeah, well, I think the stars are going to be in your favor, the planets.
Thank you. I'm
Yeah.
glad. And
Yeah.
this year is the year of the tiger as well, which is my year.
Yeah.
So
my year too.
Oh, wonderful.
It's my year too. Yeah, I'm year of the tiger also.
Oh, wonderful. Yeah. So
yeah.
So hopefully the next few years are going to be tremendous. The next few years are going to be tremendous.
I try to stay optimistic and think about that. You know, like you are sort of a light in the dark tunnel for me. You are, because you're like, you know, you're like the last straw for me. I'm hanging on for dear life. And I'm also looking at this alignment of these planets that are coming up in a couple of years. So
well, thank you. That really encourages me, because I know people need they need to see a bright future, and I'm and this is why I spend time, you know, talking to the public, because people need to see that there's a really bright future for us, and there's hope. And you know, Feli, I was talking about that yesterday in my live that I do at the foundation. Is like, you know, you look at what's going on, for instance, in Canada right now, and you know, whichever side of the aisle you're on, or whichever side of the debate about, you know, COVID you're on, whatever, what's beautiful is that you can see that people are unifying. And when people unify, what is the most, you know, what is the energy, what is the feeling that people get individually from that, is a feeling of companionship, a feeling of love for each other, a feeling of common destiny, of, you know, and that is so powerful. And it comes from, unfortunately, at this time, you know, some very, very large difficulties. So when you look at the difficulties, look at them from the perspective of this amazing opportunity that to unify humanity, you know, to unify humanity, for people to express their love for each other, to express their love for not only their family, but the family of humans. You know, in the case of the Canadians, they're expressing their love for their Canadian fellows, but, you know, it extends to the American fellows that are all up there, you know, manifesting with them and all this. And, you know, and so I believe that, you know, although it's difficult right now, there is this opportunity. It provides this opportunity for us to really do something remarkable. So I like to concentrate on that part, you know, and in that sense, you're not ignoring the difficulties. You're just seeing the opportunity they provide for people to transcend their limitations and reorganize our society in a society that has less corruption. We'll just put it that way. And more of a common goal for all of humans, not for just a few, right?
Yes. Yes.
Oh, Nassim.
Yes.
Thank you. And thank you, Rosemary.
Thank you very, very much, Nassim.
Thank you. My pleasure.
And if you don't mind, Nassim, I hope we have time for one more question here. Russ is on here.
Yeah.
Russ, would you mind sharing a quick question for us as we're
trickling out? Yeah, there you go. Where are you at?
I'm in Western Washington, a place called Tahuya. It's on the Hood Canal.
Oh, wow. Must be beautiful.
It is absolutely beautiful here. It's rainforest. We live in a rainforest.
Yeah, I can see in your window. Yeah. Yeah. There's good climbing around there, no? Is it near Leavenworth? What is that?
Climbing
Bulgarian village.
Tahuya?
No, Leavenworth. Yeah.
Leavenworth, yeah.
Oh yeah.
I used to go climbing there. It was so fun.
Okay.
Yeah.
So my question has more to do with physics, but I just wanted to say, you know, the Beatles answered the big question. You know, all we need is love. Yeah.
That's right. I know. How to get there is to unify.
Anyway, my question is, what is the relationship between electrostatic fields, like, you know, the attraction and repulsion of positive and negative charges, and gravity? How are those related?
Well, that's a deep question. Currently in physics, not related.
I know.
Either than by necessity, well, it was abandoned, although it gives the correct answers. Either than by the Bohr radius, that is, you know, the electrostatic charge and the electrostatic charge between the electron and the proton is compensated by the Newtonian forces, or, you know, the centrifugal forces of the electron in the Bohr model, which was abandoned. It's not clear because gravity is not included in these Newtonian forces, because gravity is thought to be too weak at the atomic level. All this gets resolved, I'm sorry to say, in the paper I'm writing right now. So I'm going to give you a hint. Okay, so electrostatic charge, well, charge, period, it has no source in the standard model, although it's clearly related to angular momentum, right, in an electron. And they missed the clue. And the clue is that the gravitational component of the proton, okay, is called a strong force.
Right.
And I know you say right, but for them, no, right? But for us, yes, right? Because we show that the strong force is just the Yukawa potential of the gravitational force near an event horizon. That is, gravity is a weak force, but only away from an event horizon.
Well, yeah, if you include all of that into the proton, all of the Plancks into the proton, there's a lot of gravity there.
There's an extraordinary large force there. Yeah. And that force, and you know, the idea that gravity is weak, is the weakest force, is completely wrong. Actually, Wilczek made a good comment at one point. He said the problem is not that you know, why is the strong force so strong, is why is the mass of the proton so small? And this is the error, right? And so what I'm saying, just to cut to the chase, is that you have a singularity at the center of a proton. Yeah, when you're looking at a proton, you're looking at a black hole. Like all black holes in the universe, it has the power to overcome electromagnetic fields, right? It's the gravitational field that is the definition of a black hole, where the gravitational field is stronger than gravity. So I don't know why they would think that gravity is a weak force when they can see black holes, right? Like, okay, but that's another story. It's because they don't know the source of mass. If you say that to a physicist, they'll tell you, oh, well, yeah, but you need a really large mass. And that's wrong. That is so wrong. You actually don't need a really large mass for a black hole. You just need a high density, a high energy density. So it's just they don't understand the source of mass. So of course, you know, they're all confused about this. So you put all this together, and you find that, like, you can see, like, when you do the math for the proton, you can see that the angular momentum, right, is going to produce, like, the flow of the Planck fluid of space-time is going to produce the electrostatic field. So you can see a direct mathematical relationship between the flow of the Planck field and the electrostatic field, or the electric, or the charge of the system. And you can see that it has a strong gravitational field in the middle that we call the strong force, but that field drops with the velocity of the flow of the Planck field. That is, the velocity drops very, very quickly, like faster than, like, a Yukawa potential, if you know what I mean, right? So a Yukawa potential is even faster than an exponential, right? So it drops really fast because the velocity of the Planck field drops super fast, right? And then as it drops, so then you get to weak gravity far from it. And when you do the math of all this, so you got a black hole in the middle, that's a proton. The mass of the proton we measure is the mass after the Yukawa. So it's screened. We only see a very small portion of the energy, right? And then, but we see the force, we call it the strong force. And then, you know, you have the electron way out there, which is the result of the Planck field that's spinning around that black hole. It's like the ergosphere of the black hole. And when you calculate all this, all the forces, you know, go to equilibrium to produce the electron cloud at the Bohr radius, to produce the radius of the proton at the radius of the proton, and all the forces and all the energy. So it's in perfect balance. And that's why the thing can spin, you know, billions of years, right? And not get disturbed at all, right? Like, protons don't decay, right? At all, zero.
So I'm getting that the electron then is part of this whole system.
Right.
And so therefore, if you pull the electron away, now you end up with a net positive charge.
Right.
And then it's attracted back.
Right. But then, okay, this is a really good statement you just made, because I was discussing this with other physicists in the last few months, and they were talking about, but what about a free electron? As if there was such a thing. And and engineers think that way, and physicists think that way, and it's all significantly wrong. Meaning, there's no such thing as an electron that's just flying around doing, like, that's not in relationship to a nuclei. And this actually, that video from Veritasium made that point very, very clear. You should go and check it out, right? Because Maxwell's equation clearly show it's not electron flows, it's not electron moving that produce charge or electric fields, right? It really isn't. The electrons are not going anywhere. They're not moving. They're in orbit around the nuclei. And it's just that they oscillate. So when they oscillate, they produce an electric field. But that, again, that electric field is in the space around, it's in the field. It's not actually transferred through the electrons. And that...
So when you move charge through a wire, you're not moving electrons.
Right. Electrons are not, you know, flying around. They're not, you know, these are misconceptions that were made to make it easier to do engineering, to think of it that way. but it's actually completely incorrect. And we know it's incorrect. It's just that engineer, and if you look, Veritasium got a lot of pushback from all the engineers. There's all these videos from other engineers, you know, talking about, oh yeah, but it's Maxwell's equation, we can ignore them, right? We'd rather think of it this way. And this is why we don't have free energy. This is why we don't have vacuum energy, right? Is because we reduced it to something that is not true. And because it's not true, we don't see that, wait.
We're stuck there.
Yeah, we're stuck there. Like actually energy is in the field and transfer of energy is a field effect. And what about if we resonated with that field in a certain way? Okay. We could get charge or electric fields directly from the field, right? But that's completely missed because we've reduced it to like something completely wrong, right? Okay. Yeah.
Wow.
Did that answer your question?
Yeah. I'm just wondering about the Planck though. I mean, the Planck is the Planck a wavelength? Is it?
Yeah, you can. The Planck is an oscillation, just like the proton.
Okay.
So it's a mini black hole, teeny black hole that is made of smaller black holes that are called subplancks. Okay. But the subplancks are spinning faster than the speed of light, so they're beyond. And actually, that's how entanglement happened. The information is transferred by the subplanck flow, which is going at 10 to the 40th faster than the speed of light. So of course, to us, it looks instantaneous. And, you know, and without knowing that, you know, entanglement looks like a miracle, you know, in physics. But knowing that you can actually account for entanglement, does that make sense? Like you have smaller black holes making larger ones, making, you know, they make a smoothie at different scales, right? They make a vortex, a toroid at different scales, and we call them subplancks, plancks, protons, stars, or planets, stars, galaxies, you know. And so on.
So the relationship between the size of a Planck to the relationship of a proton is the same as the relationship of a proton to a black hole out in outer space.
So yeah, so if to be more precise on the scale, the size of a subplanck to the proton.
Okay.
Let me remember. No, the size of a subplanck to the Planck is the same as a Planck to the universe. Oh. So the Planck's in the middle.
Okay.
Yeah.
So is the Planck then what determines the, since it's the wavelength, does it determine the highest possible electromagnetic frequency?
For our size universe.
Right.
So
therefore
it's all tuned in relative to each other, right?
So then that would in turn determine the speed of light.
Correct. And that's why the speed of light is the speed of light. And from our equation, we naturally pull out the speed of light, showing why the speed of light is the speed of light. Is literally as a result of the viscosity of the Planck field at the scale of our universe.
Cool.
Nice, huh?
Yeah, it's been wonderful talking to you. I love it.
Thank you. I appreciate. I love technical questions.
I've been teaching electronics for 30 plus years, and just recently, this year, they closed the electronics program.
Oh, no.
It's like, why are you closing the electronics program when there's such a high demand for electronics technicians?
Right. Well, I can't find them for my lab, by the way. So like, Maybe you can help us.
I volunteer.
Wonderful.
Can I work from home?
Yes. Send us your resume, please.
Okay, I will.
At Taurus Tech.
Okay.
Yeah.
Wow, well, look at this. Thank you, Russ. I mean, wow, I couldn't have imagined a better close on this, Nassim. You're sharing you shared your vision for humanity, your optimism for us as a species with the technology that's coming out. You got into some of the nitty gritty with your paper that's about to be published. So I think I could speak for us all. We're all on the edge of our seats, just in patience, in patient anticipation for what comes out this year and the next couple of years. So thank you, brother.
Yeah, I know it's been a long journey, and I've been talking in the future for a long time. It will come out. I'm just making sure that it's so rigorous that there's absolutely no holes in it. And there's a few thousand equations that are related to another few thousand equations. And so it's complex, and so it takes time, but I swear it's gonna come out this year.
Well, thank you, brother. And thank you for this course that you share with us. You share a glimpse to make it accessible for us many who may not be technically inclined. Thank you for sharing this with the community, for sharing your insights, your vision, because this is your time. You've been talking about this time for some time now, and we're just all appreciative. We all appreciate your work and your willingness to share with us the power that's coming from this.
Thank you. I appreciate it. I'm really honored to be able to do that piece and contribute my little piece to this amazing mosaic of humanity. I'm very, very enthusiastic about the next few years, and I'm enthusiastic about today. I'm looking at everything that's going on in the world today, and yeah, there's a lot of problems, but these problems were always there, and they're being brought to the surface for everyone to see and for us to resolve them. And so I think it's really, really wonderful.
Yes, it is. And yes, you are. So thank you all for being with us, and thank you for taking this voyage. We've come back to shore, so to speak, and we hope that in some way we can continue this journey, set sail out to another destination at some point.
Thank you. I appreciate everybody. Have a wonderful, amazing day, and until we see you again, may the vacuum be with you. Thank you so much.
Thank you. Love you all, and God bless.
Bye-bye.